Hello all. So in this video, I'm going to explain about the LeetCode daily challenge of 8/7/2022. Okay, the problem is paint house 3. Okay, in this problem, there is a M houses which are arranged in a row in a small city, and each house must be painted with one of the N colors. Okay, colors are labeled from 1 to N. Okay, some houses already painted. Okay, we don't want to paint that house again, and the neighborhood is a maximal group of continuous houses. It's a very important one. Okay, neighborhood means the maximum number of continuous houses with the same color. For example, where in these houses are arranged in a row, so the neighborhoods are, there contains 5 neighborhoods. So the first neighborhood is this one, and the second neighborhood is this continuous 2, and third neighborhood is this 2 continuous 3s, and fourth neighborhood is this single 2, and fifth neighborhood is this continuous 2 ones. Okay, these are the 5 neighborhoods. Okay, so they given a house and also m cross n matrix, which is cost, and an integer target. Okay, this is the input they given us, and the house means the color which are the house which is colored with the particular color. Okay, if the house of I is 0, that means the house is not painted yet. And also they give us cost matrix. So this cost matrix will tell us how much cost is take to color the house I with color j plus 1. Okay, so we want to find the minimum cost of painting all the remaining houses in such a way that there are exactly target neighborhoods. Only target neighborhoods must be there, and also we want to find the minimum cost to paint all houses. If it is not possible, we want to return the -1. Okay, in this first example, there are 5 houses and the 5 houses are not colored yet. Okay, we want to color that. Okay, one of the optimal way is, we want to color the first house with first color. Okay, with this color, and the second house with second color, and the third house with second color, and the fourth house with first color, and fifth house with first color. Okay, so there are number of neighbors 1 and 2 and 3. So there are 3 neighborhoods, and the array contains 3 neighborhoods which is matched with our target, and the cost of this is 1 plus 1 plus 1 plus 1 plus 5. Okay, this is 9. Okay, this is the minimum cost we can get from that. Okay, okay, now let's look at the second example with, okay, with the algorithm. So when we solve this problem, we can come to know that it can be solved using recursion, but it could take lots of time. Okay, we can reduce, because there are more repeated same problems are solved again and again, because maybe take this house or the paint with this house, this maybe lead us to another solution. If we painted with this house, this also maybe lead with another solution. Okay, okay, there are multiple possible ways, but if we solve one problem, we can reuse that solution. Okay, in recursion also always we can reuse. This concept is called memorization. Okay, we can solve this problem using memorization concept. um, in memorization, okay, we use dynamic programming approach. In dynamic programming, uh, we use three-dimensional DP. In three-dimensional DP, why we need to three-dimensional DP in this problem, I will explain in the algorithm section. Okay, now we'll move on to the algorithm part. Okay, let's take that. Okay, I will take the, okay, this is our example, second example. So this is the houses which is painted. First house is not painted yet, and also fifth house is not painted yet. Okay, and the cost matrix is this is, so there are 2 colors are there, 1 and 2. Okay, there are 5 houses. So to paint first house with 2, first color is cost 1 and second is 10. So this the same way the cost matrix will tell us. Okay, okay, we want to find the minimum cost to paint the house. Okay, first of all, so first we want to declare in every recursion problem we use the dummy node. Okay, which is called initial node. Okay, for example, okay, uh, okay, initial node. Okay, this is 0th node. Okay, this is 0th node. from this, consider this is the zeroth house, the imaginary house. From this house I can paint with color. I want to paint with first house. Okay, I will tell this. Okay, this is the first house. Okay, I can paint with this first color or in second color. Okay, okay, in second color. Okay, if I take the first color, okay, with the cost is to paint the first house with first color is 1. Okay, the cost will be 1 plus, okay, cost of other possibilities. Okay, from this, okay, we want to weight that. So, and the previous color is 0 and this color is 1. So our target is in the second example is our target is uh, um, the second example our target is 3. Okay, so target equal to 3. Okay, first we need to our target is now reduced because our previous color is 0 and the current color is 1. So there are two neighbors. Okay, so our target is currently in this point is 3. Now it's reduced it to 2. Okay, and if I take this, okay, I will move on. Okay, in the next part I will color with, okay, now I colored with the first house with the color 1. Okay, now I have two possibilities now. So now I want to color the second house. Okay, color the second house. Okay, there are also two possibilities. Okay, one possibility is I can color with either with 1 or again 2. Okay, so now the cost, okay, color with the first is, okay, first color is 10 and the second color is 1. Okay, how much? Okay, it will cost us is 10 plus something in upcoming possibilities. Okay, again now you can see the previous color is 1, this is also 1. So we don't want to reduce that. The same group, remaining group will be continued. Okay, we need new, our target is still continuous. So our target is now 2. Okay, again in this point the cost is 1. Okay, but the colors, neighbor colors are changed. Okay, this is 1, this is 2. Okay, this change, so we reduce the target, so the target is now come into 1. Okay, now it also has two possibilities. Okay, whether it can be colored with 1 or it can be colored with 2. Okay, now move on. So now I pick the first one. Okay, now I move on to the first part. Okay, if we have, so now I'm going to color the third house. Okay, again I have two possibilities. I may be colored with 1 or I can color with 2. Okay, if I colored with 1, okay, again I want to check whether the what is the cost of this. The third house with paint 1 is 10. Okay, okay, plus 10. It is not changed because it is same as the previous color. So the target also remains same. Okay, it is plus 10 means it will go under it deeper. Okay, next is this house 1. Again it will change the color to 2. So the two colors are different. Okay, so its target is changed to 1. Also the uh, cost is 1. Okay, plus 1. Okay, now again I want to move to next house. Okay, house number 4. I take this okay, this possible way. Okay, again it has the way I color with 1 or I may color with 2. Okay, now again I want to check the previous state. Okay, so now what is the cost to color the fourth house with color 1? I want to check in the cost matrix. So with was 1. Okay, I will color with plus 1. So the previous color is maintained, so I don't want to change this. So it will be remain 2, but this color is changed. So 2 comma 1 will be 1. Okay, now okay, this cost is again 1 plus 1. Now I move on to next to house, final house. Okay, in final house there are two possibilities again. It may be 1 or it may be 2. Okay, in final house the cost is to color the with first painting is plus 5. Okay, it is plus 1. Okay, the team of number of group is it's compared with previous colors, say both are same, so I did not reduce the previous number of groups will be continuous. So till our target is till 2, and if we choose the second color, our target may to reduce into 1 because the color is changed. So target is 1. Okay, you can see now we reached the end. Okay, we colored with all paintings. We colored all houses in this part. Okay, now this is not a optimal. This not give us the this not reached our target because still two groups must be formed because you can see the tree. Okay, we colored all this with only one color. Okay, so there are still two groups must be formed. This only one groups are formed, continuous ones. Okay, this is one of the possibilities. Okay, again I want to explore the other routes also. Okay, it may be take lots of time. To reduce this time complexity, we want to memorize the states. Okay, I know the states of this. I know the answer of this states. Okay, this is not a possible answer, so I will return the max. Okay, so if we reach the final but we did not get the feasible solution, we return the larger value. Okay, to reduce to check. Okay, to avoid the conditions. Okay, we return a large value, so it will become like int. Okay, int max. Okay, m, right? So m plus 5 is max. Okay, the same way it will also return max value. If it is reached the feasible solution, it will return 0. So 0 plus 5, 5. It will return the 5. So 5 plus 1, 6. It's 6 or like that. So we store these values into the DP matrix in 3-dimensional matrix. Okay, why we store this? Because if you explore this, you can try in your own way. Okay, try to explore this way. You can see many problems are repeating again. Okay, we can directly return the values by using this memorization table. Okay, we don't want to explore all nodes. It can be directly written. Okay, the DP table is which is 3-dimensional. We need 3 dimensions. Okay, 1 dimensions for first our houses. Okay, number of houses. Okay, first is number of houses. Second is target. Okay, may I reach the node this? Maybe I reach this house with which target? I reach this house with already with target 2. Okay, this. So second dimension is target. Okay, third dimension is paint. Okay, which color I painted before? Okay, before which color I used to paint before house? Okay, so third dimension is paint. Okay, I recursively call this value, but also I stored it in this DP. If I already solved this type of state, I return the DP value again. If I not solved this type of state, I will recursively call the state. Okay, so this is the concept to solve this problem. I hope you understand. If you did not understand, please take note, pen and note, and try to draw this state space tree of this problem, and you can clearly understood it. It's a hard problem, but if you draw the state space tree correctly and you understand the concept, it is a very easy to solve you. Okay, now let's look at the code part. Okay, so in this code I used 3-dimensional DP. I already said. Okay, it's a global DP, and I declared integer max value which is 10 power 7. Okay, to reduce the, if I use int max, it will go overflow. So in addition, so I used the max value. Okay, and I used the DP dot. Okay, I resized it with the. So I already said this is the number of houses, and second dimension is target, and third dimension is colors. Okay, n is the color. Okay, now I call the DFS. Okay, house. Okay, I do DFS operations, or I mean recursion also. Okay, same way. Okay, I do DFS, or you can also do BFS also. Okay, in this DFS is the base condition. If the target become negative, okay, we found more number of groups, which is like, for example, if we record only 3, but we formed 4 groups, so it is not feasible. I directly return the max value, which indicate that our answer is not feasible. Okay, if our current house is greater than the house dot size, okay, we paint all house, we try to paint the another house which is not there. For example, there is only 5 houses, but we try to paint the 6 house, means we painted all the houses. Okay, in that condition, we check whether our target groups are achieved or not. If our target group reaches the 0, which means our target is achieved, we return 0. Otherwise, we return the max value. Our target is not achieved. Okay, in the next state, we check whether we already solved the problem or not. Okay, and first initially I filled the DP with -1. Okay, if I already solved this problem, I return this DP value. Okay, which is current house. Okay, I will explain this. This function will take uh, 5 parameters. First parameter is houses, and second parameter is cost matrix, and the third parameter is which house I currently there, and the fourth parameter is how many neighbor groups neighbors should be formed, target, and the fifth parameter is previous color, which color I painted previously. Okay, I call this function with initially I had the imaginary house, which is 0th house, and also imaginary color. It's a okay, it is a starting node or the imaginary node. Okay, to start this recursion call. Okay, if I already solved the problem, I return the values which are stored in the DP. Okay, if the color is if the house is colored already, I store in the DP. Okay, I call the DFS with the same house. I move if the house is already colored, I move to next house, and I will check whether the house is colored. It is not same as the previous place. If the current house color and the previous house color is not same, I reduce the target by 1, and also I change the previous color to this house's current color. So this is a recursion call, and then again I store this into DP and return the DP value. Okay, if it is the house is not colored, I want to check all the other colors. Okay, I can paint all the other colors, possible colors. Okay, I iterate over from 1 to all other colors. Okay, so I call the recursion call for all possible colors. Okay, for example, I try to paint the first color with the current house, or second color with this current house. So which is give us the minimum value. I will take store in the minimum color value, and finally I store into DP and return the value. Okay, so this is the code for this problem. Now I try to submit this problem. Okay, it is accepted. Okay, so now we can we want to know the time complexity and space complexity. Okay, we use the three-dimensional DP. So the space complexity is order of n into target into m, and also the time complexity also will be same, because we want to, you can see in the recursion. So we use the recursion call. We want to check every target value, and also it in worst case time complexity will also n cross m into target. It's a worst case scenario. Okay, I hope you enjoyed this session. Okay, if you have any doubt, please let me know in the comment section. So to more any other doubts also, you can ask me in the comment section. Okay, thank you for watching. Let me see in the next LeetCode daily challenge. Thank you.